So in this video, we're going to see a data structures 1 mark question from the year GATE 2020 and it's based on the topic of binary search tree traversal. So let's see what the question is. The pre-ordered traversal of a binary search tree is as given in the question. Now, which one of the following is the post-order traversal of the tree? So we are given a pre-order traversal of a binary search tree. It's not a binary tree, note that point. It's a binary search tree. And we have to find the post-order traversal of this tree. So before we start solving this question, let's quickly see what is the post-order traversal of a tree. Okay, so let's assume this example here. We have a tree with plus as a root and A and B as its left and right nodes. So the pre-order traversal of this tree is plus A and B. So this is the pre-order traversal of this tree, plus AB. Now the point to note is we are first visiting the root, okay, then we are visiting the left node, and then we are visiting the right node. Okay. So the point we should remember is that in pre-order traversal, first we visit the root, then the left, and then the right. That's how the typical definition of pre-order traversal is. Now we are going to apply this definition of pre-order traversal to the given sequence and try to reconstruct the original binary search tree. Now in order to do that, first I'm going to note down this entire list of pre-order traversal. So let me quickly do that. 15, 10, 12, 11, 20, 18, 16 and 19. Yes. So this is the pre-order traversal sequence. Now when pre-order traversal sequence was written down, they must have followed this algorithm: root, left, right. So the first node that we visit is the root, which means that the first value in this pre-order sequence 15 is going to be the root of the tree, because that is what the definition of pre-order traversal says. First we visit the root. So very clearly the number 15 is going to be the root of the tree. So I'm going to write it down here. 15 is going to be the root of the tree. Now since it's a binary search tree, as per the property of binary search tree, everything to the left is going to be less than 15 and everything to the right is going to be greater than 15. That is the property of binary search tree. So let me quickly note down things which are less than 15, that is 10, 12, 11, and things that are greater than 15 is 20, 18, 16 and 19. Okay, so this is how the tree will get split in the left and right. Now once again, let's focus on this left subtree. In the left subtree, it is also a pre-order sequence. 10, 12, 11 is also a pre-order sequence. So once again, this property applies, that the first value which will get visited is going to be the root. So the first number that will come into this is again going to be the root. So once again, 10 is going to be the root here, okay, of this left subtree. And since it's a binary search tree, less than 10 to the left, greater than 10 to the right. So there's nothing less than 10 here, so I'm going to make it null. And greater than 10 is, we have two numbers, 12 and 11. So the sequence matters. 12 and 11 is the input sequence here. So the same way we have to write it. Don't mess up with the sequence. Now once again, in this 12 and 11, it's a pre-order sequence. So whenever it's a pre-order sequence, we very confidently can apply root, left and right property. So the first value always has to be the root. So 12 is going to be the root here, and less than 12 is 11. So it comes here, and there's nothing greater than 12. So that's null. So this is how the left subtree of this 15 was the original root. Now this is the left subtree of the 15. Now very similarly, we are going to construct the right subtree of the 15 using the same logic that we have applied so far. We are going to use property of pre-order traversal and property of binary search tree, combine the both and try to reconstruct the tree. So I'm going to be a little fast here. I hope you have got a hang of it. So 20 is the first value in the pre-order sequence. 20 has to be the root. So 20 will be the root. Everything less than 20 will be to the left and everything greater than 20 to the right. So less than 20 we have, everything is less than 20. So 18, 16 and 19, all these things will be less than 20, greater than 20 will be null. Again note, the sequence that I write is exactly same as it is above, 18, 16, 19, 18, 16, 19. Okay, then let's go ahead. Now 18 is the first number in the pre-order sequence, so it has to be the root. So 18 will be my root here. Less than 18 is going to be 16, okay, and greater than 18 is going to be 19. So that's how my left and right nodes will get split. And thus we have now reconstructed our pre-order sequence. This was my pre-order traversal sequence into a binary search tree. Okay, now let's quickly rewrite this tree so that is easy to follow up. So 15 and 10 comes here and 20 comes here, okay, and then okay, this is less than 10, nothing. So here comes 12 and here comes 11, okay, and then 20, there is nothing greater than 20. Less than 20 we had 18, and then we had 16 here, and we had 19 here. Yes, so this is my original binary search tree of whose pre-order sequence was given. Now the question had asked find its post-order traversal. So let's see what is post-order traversal first. Let me draw a line here. Okay, so let's quickly see what is post-order traversal. So let's again consider a simple binary search tree as we had seen before, plus A and B. Okay, for this binary tree, the post-order traversal is going to be A, B and plus. Okay, now again the point to note is we are first traveling to the left, then we travel to the right, and finally we travel to the root. Okay, first we travel to the left, then to the right, and finally to the root. This is our post-order traversal definition. Now let's apply this definition. Let me zoom in a bit. Yes, let's apply this definition to our binary search tree which we have constructed. So first I will be at this root. So this is my first node that I'll be visiting. Now as we see, we have to go to the left. So I will come to the left of the root. So I will come here to 10, and then again from 10 I will go to the left, but left is null. So left of 10 is completed. Now I'll go to the right of 10. So here I come to the right of 10, 12. Now once I'm at 12, again first I should go to the left. So I go to the left. Okay, this is 3, and then I go to the left. This is 4. Now once I'm at 11th node, I will again follow this definition, left, but left is null, so nothing to visit. Then right, so right is also null, nothing to visit. And then the root, so root is 11 itself. So 11 thus gets visited, and I'm going to make a note of it. 11 is going to get visited. Now once 11 is done, we backtrack. So we go to this third position where we were before. Now if you think about 12 as a node, its left is visited. So right is remaining, but right of 12 is also null. So left is done, right is done, then the root itself is visited. So 12 will be visited. So I'm going to strike it out, and then I'm going to go back. So now I'll come at node 10. Now again, think of node 10, its left is visited, its right is also visited, then the root will be visited. So I will strike out 10, and I'm going to make a note of it here, 10, and so on. So this is how my post order sequence is going to be. I've got the first 3 numbers in the post order sequence. So instead of finding the entire post order sequence, let me quickly see if any of the option has this 11, 12, 10 as the starting 3 numbers. So let me zoom in. Okay, 11, 12, 10, here it is. If you look at option B, then option B has the starting number as 11, 12, 10, and thankfully that's the only option which has this. So without wasting our time, because time is premium in any competitive exam, so without wasting our time, we no need to find the entire post order traversal. We quickly go and mark option B as our right answer.